Hi, it's Miss Townsend. Let's try this question. We're given a quadratic relation in standard form, and we have to find the roots, the vertex, and the y-intercept. So we know that to find the roots, the best way to do that is to have a factored form equation. So I'm going to ignore the y equals and just write the expression x squared plus 14x minus 9 and just work on factoring that first. So I can't common factor anything, and I definitely have a complex trinomial. So how do I factor them? Well, I need to look at the a and c values, 8 and negative 9. If I multiply them together, I get negative 72. So I need to find two numbers that multiply to give negative 72 and add to give positive 14. So 8 times 9 is 72. That comes to my head right away. But we need to have some sort of system, because what if 8 and 9 don't work? I need to know for sure what the two numbers are, or maybe they don't exist. We got to figure that out. So the process that we use, and I'm just going to go a little bit lower on the page here, as I start to write out all of the numbers, all of the pairs of integers that multiply to give 72. So 1 times 72. They definitely multiply to give 72. 2 times, and you can certainly use your calculator, 72 divided by 2 would be 36. So 2 times 36 is 72. 72 divided by 3, I get 24. And if we keep going, 72 also divides by 4. Boy, there's a lot of numbers. It doesn't divide by 5, so I don't need that one. 72 divides by 6, that would be 12. 72 doesn't divide by 7, that's a decimal. 72 divided by 8, 8 times 9. And I know I'm done the list because the next number I would test is 9, and 9's already represented on my list. So there's 6 pairs of numbers that multiply to give 72. Now I know I need to multiply to give negative 72, so one of the numbers is going to be negative. But first I want to figure out what pair of numbers could possibly add to 14. So the top two numbers, if I make one of them negative, for example, this one, that would add to 71. And if I make the other one negative, it adds to negative 71. So no matter what, I've got 71 or negative 71. That's not what I'm looking for. I'm looking for 14. 2 and 36. Again, if I make one of them negative, I would have 34 or negative 34. I don't want 34. So see how you don't have to test both of them. If the number you're looking for shows up, you can then figure out which one has to be positive and negative. So if I make negative 3 plus 24, that would be positive 21. I want 14. Negative 4 plus 18, oh, that's 14. And the signs are already where I want them to be. Negative 4 plus 18 is positive 14. And negative 4 times 18 is negative 72. So I found the two numbers. That is the first step. So now I'm going to decompose, which means break down 14x into two different pieces. One piece is negative 4x, and the other piece is positive 18x. So I'm not changing the value of the expression. That still says positive 14x. I've just broken it into two different pieces. Then I'm going to group the first two and group the second two and do some common factoring. So in the first two, both of those coefficients are divisible by 2, and both terms contain an x. So I'm common factoring 2x. This term, if I divide by 2x, I would have 4x. This term, if I divide by 2x, I would have negative 2. Close the bracket. Now right away, I found my problem. Notice how these are still divisible by 2. Boy, I sure didn't think too hard about my common factor, because I could have I could divide them both by 4. Now, if I had video editing skills, I might edit this video. But, this is how you can common factor and then notice, hopefully, that you didn't common factor a big enough number. So now I'm going to properly, hopefully, common factor 4x. 8 divided by 4 is 2, and then I need one more x. Negative 4x divided by 4x is negative 1. And now let's common factor these two. 18 and negative 9 are both divisible by 9. Do I common factor positive 9 or negative 9? Well, you always want to match whatever that number is, the sign that separates the first two from the second two in your grouping. That's what you factor with. So I'm going to factor positive 9. And that leaves me with, so this is 18x divided by 9, 2x, and minus 1. We know we're doing the right math because my bracket matches my other bracket. So I'm going to common factor that bracket. And when I common factor it, this term still has 4x, and this term still has plus 9. So I have fully factored. So now I'm going to rewrite my quadratic relation in factored form. So it's a quadratic relation because it's got x and y back together. So there it is in factored form, and now we're going to find the roots using the zero principle. So we let y equal 0, and then we figure out what value of x makes each bracket 0. So in class, I've explained my little shortcut trick, but I'll do the long cut version here. So I need the bracket 2x minus 1 to equal 0. So now I'm just going to solve for x. 2x would equal 1, and x would be a half. That's one root. I also want that bracket to equal 0. So solve for x. 4x equals negative 9. X equals negative 9 over 4. So I've written them as fractions, and I'm going to continue to do the rest of the video in fraction form. But I know that some of you might decide, ugh, I'm going to do this one in decimals. So every so often I might stop and say, well, here's what you should have as a decimal. So that would be 0.5, and as a decimal, that is negative 2.25. So I'm going to continue working in fractions, though. So now I have my roots. And again, you might want to think about writing them as x-intercepts, which would be the point. Because an x-intercept is a point, but a root is a value. I know, subtle difference, vocabulary. Those are my roots and my x-intercepts. So now I'm going to find the axis of symmetry. So remember, the axis of symmetry is a line that has an x value exactly halfway between your roots. So to find it, I need to find the average or the midpoint of the roots. So I need to add a half plus negative 9 over 4 and then divide by 2. So if you're using decimals, this is going to be a lot faster process. But let's see what happens here with our fractions. So first of all, I've got a bunch of stuff in the numerator. So I need to make that one fraction, not two fractions. So I need to get a common denominator. So I'm going to make this first fraction have a denominator of 4. To do that, I'm going to multiply both top and bottom by 2. So that's 2 over 4 minus 9 over 4. And because I put the equal sign, I have to make it equal. So it's still divided by 2. So in the numerator, I have 2 minus 9 is negative 7 over 4 divided by 2. And now we have finally one fraction in the numerator, and I just have to figure out what's happening with this. So this number, negative 7, was divided by 4, and then divided by 2. So really what I've done is I've divided negative 7 by 8. So this is negative 7 over 8. So the axis of symmetry, so I'll just put AOS, is the line x equals negative 7 over 8. And of course, if you're using, oops, I don't want two equal signs, I'll use a colon. If you're using decimals, then you would have negative 0.875. Let me just double check that I did that in my calculator. Hooray! So you would have, I mean, it looks nice to say negative 0 point there. So that's it as a decimal and as a fraction. And of course, once you have the axis of symmetry, you can find the vertex. Notice that the original question didn't actually ask me to find the axis of symmetry, but we need it because without the axis of symmetry, how do we find the vertex? So I found it anyway because we kind of have to. So the vertex has an x-coordinate of negative 7, 8 over 8, and now I just need to find the y-coordinate. So I'm going to find, let me go up here, Go up here. I need my factored equation. So let me see if I can copy it so I don't forget it and have to keep scrolling around. Did that work? Oh, it did, sort of. Just jumped around a little bit. Okay, so that is the factored equation I'm working with. And now I know that the x value I'm interested in is -7/8. So again, if you're using decimals, this is going to go a lot faster. But it's always good to stretch our math and try to do it with fractions. So I've just substituted the fraction, which is the x coordinate. And now I just have to do the math. So let's see. Inside this bracket, well, first I'm multiplying 2 times -7/8. So that's -14/8. And of course, that reduces. And I'm going to want to reduce it. So I'll do that in the next step. But probably in math, I would, if this was just on paper, I would just erase it and put this simplified. 4 times -7, so I'm onto this next bracket. 4 times -7 is -28/8. And again, that also reduces. So let me reduce those fractions. This is, they both divide by 2. So this is -7/4 minus 1. And this is -24. No, sorry, this is negative. They both divide by 4. So this is -7/2 plus 9. And now, within that bracket, I'm going to get a common denominator so I can subtract. So instead of 1, I'm going to have 4/4. And instead of 9, I'm going to have 18/2. So the first bracket is -11/4. Oops. And the second bracket is -7 plus 18 is 11/2. Now, finally, I can multiply those brackets together. So notice I'm following Bedmas. I'm doing what's in the bracket. And now, finally, what's in the bracket is resolved, or as mathematically simplified as possible. And I can finally now multiply the two brackets together. So -11 times 11 is -121. And 4 times 2 is 8. And that doesn't simplify. So the vertex is -7/8 and -121/8. So if you were using decimals, you did that a lot faster than me, but you'd have a sort of more complicated thing to write down. And certainly I assume you would have round your decimals at some point, but that's what you should have if you kept exact values. So there's the vertex. So again, you know, it's always good to push yourself. But if I scroll back up to the question, we can see that I also wanted to find the y-intercept. Now the y-intercept is really the only good thing about standard form is the easiest form to find the y-intercept. No matter what, to find a y-intercept, you let x equal 0. So if I let x equal 0, well, 0 squared is 0. 0 times 8 is 0. So that whole term is just 0. Same thing here. This is 14 times 0, which is just 0. That whole term is just 0. So if x is equal to 0, the only thing I have left numerically is -9. So the y-intercept is -9. Now, what I like doing, if you have time to do it, is take the other form of that quadratic, so the factored equation, and sub-zero in there as well. And make sure you also get -9. So if I let x equal 0 here, then I get, well, 2 times 0 is 0. 0 minus 1 is -1. In the other bracket, I have 4 times 0 is 0. 0 plus 9 is 9. And if I multiply them together, I get -9. So, yay. That's definitely the y-intercept. You don't need to do it twice, but it's sometimes nice to check your work. I hope that was helpful. Keep practicing your math.